For 20 years, wildlife biologists in the Florida Everglades told anyone who would listen that the Burmese python was unstoppable. Not difficult to manage, not a significant challenge, unstoppable. The snake had no natural enemies in the swamp. It outgrew everything that had ever tried to kill it. It reproduced faster than anyone expected, and it ate almost everything else down to almost nothing. Bobcat populations dropped by over 87%. Marsh rabbits were nearly gone. Raccoons down 99% in some survey zones. Opossums down 98%. The numbers were so bad that even researchers who had spent their careers avoiding dramatic language started using words like ecological collapse. Then, something changed. Beginning around 2019, field researchers started finding something they had not seen before. Python nests were being raided. Eggs were being destroyed. Hatchlings were turning up dead in places where they should have been safe. Adult pythons were being killed. Not by hunters, not by traps, not by government removal teams, but by animals that had been there the whole time. Animals that the scientific community had largely written off as too small, too slow, or simply not built for that kind of fight. What followed over the next several years reframed everything researchers thought they understood about how ecosystems actually defend themselves. And what happened in the Everglades during that period has implications that go far beyond one snake in one swamp. This is the story of how Florida's native predators started hitting back, what they did to python nests across thousands of square miles, and why the scientists watching it happen could not quite believe what they were seeing. Before we get into it, if you want to catch every new documentary we put out, hit subscribe right now and turn on the bell notification. We release new episodes every week, and you will not want to miss what is coming. Now, let us get into it. The Burmese python arrived in Florida the way most invasive species do, not through any single dramatic moment, but through a long accumulation of small decisions that added up to a catastrophe. Pet owners who could no longer manage animals that outgrew expectations. Hurricane Andrew in 1992, which is believed to have destroyed a reptile breeding facility near Homestead and released a significant number of large constrictors into the wild in a single night. Decades of importation for the exotic pet trade, with estimates suggesting tens of thousands of snakes had entered the state before regulations tightened. The Everglades was almost perfectly suited to the python. The temperature was right, the water was right, the prey base was enormous, and there was essentially nothing in the ecosystem designed to keep a 12-foot constrictor from doing whatever it wanted. By the early 2000s, researchers were already alarmed. A landmark study published in the Proceedings of the National Academy of Sciences in 2012 documented the scale of the collapse. Raccoon observations had declined by 99.3%, opossum observations by 98.9%, bobcat by 87.5%. White-tailed deer had essentially vanished from large sections of the park. Even the marsh rabbit had been reduced to near zero in many areas. These were not animals that had declined because of habitat loss or development pressure. The habitat was still there. The Everglades itself had not changed. What had changed was that a single apex predator, one that had not been part of this ecosystem for any of its evolutionary history, had moved in and started eating everything. The python's method is efficient to the point of being almost mechanical. It waits. It strikes with extraordinary speed for an animal its size, and then it constricts, using the pressure of its coils to stop blood flow rather than to crush bone. The python is genuinely good at what it does, and in the Everglades for a long time there was almost nothing to stop it. By the early 2010s, the state of Florida had launched a python removal program. Professional hunters were being paid bounties. There were public hunting events. Scientists were developing radiotelemetry methods that involved surgically implanting trackers in snakes and then using those Judas snakes to find breeding aggregations. Every tool available was being aimed at the problem, and the problem kept getting bigger. Before any of the changes started showing up in the field data, the scientific understanding of python reproduction in Florida was fairly well established, and it was not encouraging. Burmese pythons are seasonal breeders in their native range. In Florida, the breeding season typically runs from late fall through winter, with females laying eggs in spring and early summer. A female python that has reached reproductive maturity, which typically happens when the animal is 4 to 5 years old and somewhere around 6 to 8 feet long, can lay between 12 and 87 eggs in a single clutch. Larger, older females tend toward the higher end of that range. The eggs are deposited in a nest site, often inside a hollow log, beneath decaying vegetation, inside an alligator burrow, or anywhere that provides warmth, humidity, and concealment. And then the female does something unusual among snakes. She stays. She wraps herself around the clutch and uses muscular contractions to generate metabolic heat, essentially incubating the eggs with her own body. She does not eat during this period. She barely moves. For approximately 2 months, she is entirely focused on the nest. This behavior is part of why pythons are so successful. The eggs are not just deposited and abandoned. They are defended and maintained. The female's presence raises the temperature of the clutch above ambient temperature, which accelerates development and improves hatch rates. It also means that anything wanting to raid that nest has to go through a 12-foot snake that is highly motivated to defend what it is sitting on. Researchers studying python nests in the earlier years of the invasion found very low rates of nest failure from predation. Camera traps recorded the occasional approach from a curious raccoon or small alligator, but successful raids were rare. What changed, starting around 2019 and becoming clearer by 2021 and 2022, was that the nest failure rate started going up, and when researchers examined failed nests, what they found there told a very specific story. The first piece of the puzzle that researchers started documenting was not what most people would have predicted. Red imported fire ants are themselves an invasive species in Florida. They arrived from South America, almost certainly through shipping activity, and they have been a fixture of Florida's outdoor landscape for decades. They are aggressive, colonial, and they move fast. Fire ants had been identified as a pressure on sea turtle nests in Florida and had been documented attacking alligator hatchlings. Researchers were aware that they could potentially be a factor in python nest outcomes, but early monitoring had not shown dramatic effects. What started changing, based on camera trap data gathered by researchers with the U.S. Geological Survey and Everglades National Park, was the timing and pattern of ant interactions with python nests. Fire ants were not waiting for the female to leave. They were probing the edges of nests while she was still present, finding paths of entry through gaps in the coils or from below the nest material. In a subset of documented cases, they were reaching eggs or newly hatched young. A hatchling python is about 18 to 24 inches long and relatively fragile. A coordinated fire ant column can overwhelm a hatchling in minutes. Areas where fire ant colonies were well established and where python nest density was also high showed elevated rates of nest failure compared to areas with lower fire ant presence. The correlation was not perfect, and fire ants were clearly not the only factor, but they were a real one. There is a certain irony that researchers found difficult to ignore. Here was an invasive species putting pressure on another invasive species in ways that Florida's native fauna had been unable to accomplish on its own. Fire ants cause enormous ecological damage of their own, but in the narrow context of python nest survival, they were doing something useful. The other piece of the picture that began to shift during this period was the relationship between pythons and alligators, specifically between python nests and alligators. The conventional understanding was that alligators and pythons occupied a kind of uneasy coexistence. There were documented cases of each species killing the other. Famous photographs of pythons that attempted to swallow alligators and died in the attempt. Camera trap records of large alligators killing adult pythons. But these encounters were inconsistent and did not provide meaningful population-level control. What the new data started revealing was that the alligator's role in the python story was better understood at the scale of nest sites. Alligators dig depressions in the marsh called gator holes, and python females had been documented using these burrows as nest sites because they offered exactly the combination of warmth, humidity, and concealment that a brooding python needs. In other words, pythons were nesting in alligator infrastructure. What researchers began documenting more carefully was what happened when a resident alligator came back to a burrow that a python was using. In some cases, alligators were entering burrows where python females were nesting and not leaving peacefully. In a subset of camera trap records, alligators were documented returning repeatedly to specific locations that overlapped with known python nest sites. Not in a way that looked like casual movement, but in a way that suggested sustained interest in what was happening at those locations. The eggs themselves appeared to be part of the draw. Alligators are opportunistic feeders and have been documented consuming reptile eggs of various species when accessible. A python clutch left briefly unguarded during one of the rare moments when a brooding female might shift position represented a significant caloric opportunity for a large alligator passing through. The math here matters. A python clutch of 50 eggs, each producing an animal that could begin its own clutches in 4 to 5 years, represents a staggering compounding effect. If alligators were contributing to clutch failures even at a low rate, the cumulative effect across thousands of nesting events over multiple years could be meaningful. If the fire ant data was unexpected and the alligator data was more nuanced than the earlier narrative had suggested, the bird data was the part that genuinely caught researchers off guard. Florida has an extraordinary diversity of wading birds. Great blue herons, great egrets, white ibis, roseate spoonbills, wood storks. These birds are highly visible and well studied, and in most ecological frameworks, not predators in the sense of confronting large, dangerous prey. But what the field data started revealing was a more opportunistic picture. Hatchling pythons in the Everglades face a gauntlet that adult pythons do not. At 18 to 24 inches long, they are small enough to be prey for a wide range of animals that a 5-foot or 10-foot python would never have to worry about. And hatchling pythons, unlike their mothers, move through the environment. They disperse from nest sites. They explore. They end up in the kinds of shallow water margins and emergent vegetation zones where wading birds spend their days. Researchers began accumulating accounts of wading birds, particularly great blue herons and wood storks, taking hatchling pythons when they encountered them. Great blue herons are capable of swallowing prey up to about 18 inches long and will take anything they can manage, including snakes. Camera trap footage and documented stomach contents from birds captured for other research purposes built a picture in which hatchling python mortality from avian predation was higher than previously estimated. The wood stork data was particularly interesting. Wood storks are large birds that feed by tactile sensation, walking through shallow water with their bills open and snapping shut when they feel something. They are not choosy. In areas where hatchling pythons were moving through the shallow water margins of the Everglades in the weeks after hatching, wood storks were taking them along with everything else that happened to be in the water. The wood stork is a federally threatened species in the United States. Its population had declined severely due to habitat loss and water management changes that disrupted the Everglades drying cycles that wood storks depend on for nesting. Years of conservation effort had slowly rebuilt those numbers. By 2019, wood stork populations in South Florida were higher than they had been in decades. And those higher wood stork numbers meant more birds moving through exactly the areas where hatchling pythons were dispersing. A predator reduced to marginal numbers by other human-caused pressures was now, through separate conservation investments, showing up in the right place at the right time to address a completely different problem. Ecologists call these unintended interactions ecological synergies. Fixing one thing sometimes helps with another in ways nobody planned for. The bird story did not stop with wading birds. Red-tailed hawks, osprey, and red-shouldered hawks were all documented, taking hatchling pythons in South Florida during the same period. None of these species were hunting pythons specifically. They were doing what they always do, taking prey in the size range they can manage. Hatchling pythons at 18 to 24 inches fell squarely into that range. The adult python population never had to deal with aerial predators. The hatchlings did. By 2022 and into 2023, researchers working in and around Everglades National Park had accumulated enough data to start drawing some cautious conclusions about what was happening to python nest success rates. The picture was not clean, Nests in high fire ant density areas showed worse outcomes. Nests near alligator activity zones showed different patterns from nests in lower activity areas. The interplay of factors was complex, and longer-term monitoring would be needed before anyone could draw firm population-level conclusions. But the directional trend in the data was clear enough to be striking. Python nest failure rates in monitored areas were higher in the 2020 to 2023 period than in earlier monitoring periods. The total proportion of eggs failing to produce viable hatchlings had increased, and the causes of those failures, when researchers could determine them from physical evidence and camera footage, pointed predominantly to native species activity rather than to abiotic factors like flooding or temperature extremes. This did not mean the python population was in decline. The population was too large, the breeding too distributed, and the removal programs too limited to suggest an overall reduction. But the nest failure data suggested the population's growth rate might be lower than models had projected. Somewhere in the complicated math of births, deaths, and net population change, the birth side was being nudged downward by pressures that had not been adequately accounted for. For researchers who had spent years watching python numbers trend relentlessly upward, this was not a rescue. But it was something. The Everglades python story sits inside a broader scientific debate about whether native ecosystems can resist invasive species on their own. The honest answer is that they can, but rarely enough to prevent an invasion entirely. What they can do is slow it, create friction at the most vulnerable life stages, and impose costs that management programs cannot afford to replicate from outside. The Everglades data was showing all three of those things happening simultaneously. There is another thread in this story that connects directly to the low-cost living niche in a way that most coverage of the python issue does not address. The Comprehensive Everglades Restoration Plan, authorized by Congress in 2000, is one of the largest environmental restoration projects in American history, with a cost now approaching $20 billion. Its goal is to restore more natural water flow through the Everglades, reversing decades of drainage and channelization that altered South Florida's hydrology for agricultural and development purposes. One of the things that altered hydrology did was reduce the duration and depth of wet season flooding across large sections of the interior Everglades, with cascading effects on vegetation structure, fish populations, wading bird, nesting, and the entire prey base. When hydrology is restored and natural flood cycles return, certain areas of the marsh become more deeply flooded for longer periods. That matters for python nests. Eggs cannot tolerate sustained flooding, so nest sites need to be elevated enough to stay dry through incubation. As more sections of the Everglades see those restored flood cycles, the number of suitable elevated nest sites in those areas decreases. Nesting females have to be more selective, and the distribution of successful nests shifts. Researchers tracking python nest locations over multiple years observed patterns in which nest site selection was more constrained in areas with more restored hydrology compared to areas where historical drainage modifications were still in place. Money spent on ecosystem restoration is doing double duty in ways that make that investment more valuable than a single-purpose accounting would suggest. Python management in Florida costs real money. The Florida Python Challenge competition in 2022 attracted thousands of participants, but removed fewer than 800 snakes from a population estimated in the tens of thousands. Professional contractors and telemetry-based research programs together push the total annual spend on python-related management in Florida into the tens of millions of dollars. That money is limited. It competes with every other conservation and wildlife management priority in a state with a lot of them. Sea turtles, manatees, Florida panthers, coral reefs, oyster beds. The list of things that need management attention in Florida is long, and the funding available is never sufficient to address all of it adequately. If native biotic resistance, the fire ants, the alligators, the wading birds, the raptors, is providing some degree of free ecosystem service in the form of python nest suppression that is economically valuable, not in a way that can be perfectly quantified, but in a real sense, It means that the dollars spent on active removal programs are working on a problem that is also being worked on by forces that do not send invoices. This changes the calculation around Everglades restoration in ways that have policy implications. If restored hydrology reduces suitable python nest sites while simultaneously improving wood stork populations, which then provide additional predation pressure on hatchling pythons, then the restoration investment is generating python management benefits that are not being counted in the python management budget. The ecosystem is doing work that would otherwise have to be paid for directly. For advocates of large-scale ecosystem restoration who are trying to justify the investment to legislators and budget committees, these co-benefits matter. They are real, they are measurable in principle, and they represent a kind of return on investment that a simpler accounting framework misses entirely. No discussion of native predators and Burmese pythons in Florida is complete without addressing the Florida king snake and what it may or may not be doing out there. Florida king snakes are native constrictors, typically reaching 3 to 5 feet in length, that are ophiophagous, meaning they eat other snakes, including venomous species with apparent immunity to the venom. They kill by constriction and are known to take prey considerably larger than themselves relative to their own body mass. They are widely distributed across Florida and have been present in the Everglades throughout the python invasion. The question researchers have asked repeatedly is whether Florida king snakes kill Burmese pythons. The theoretical answer is plausible. A large king snake encountering a young python of comparable size could potentially attempt to constrict and consume it. The field evidence has been frustratingly limited. There are documented observations suggesting king snake interactions with juvenile pythons, but the data is thin. The Everglades is a large place, and the behaviors of mid-sized snakes in it are difficult to monitor systematically. What researchers have been able to say with confidence is that any king snake predation on pythons, if it occurs at significant rates, is not detectable at the population level in current data. The king snake is not emerging as a clear control on the python population in the way that some early optimism suggested it might. But the absence of clear evidence is not evidence of absence in an ecosystem this large and this difficult to monitor. The king snake question matters practically. If king snakes can impose meaningful mortality on juvenile pythons in the wild, and if their population can be supported through habitat management, that represents a cheaper and more sustainable management tool than hiring professional hunters. Researchers are not claiming it works. They are saying it has not been ruled out. By 2023, researchers who had been watching the python story for a decade or more were in an unusual position. The python population remained enormous, the damage to mammal communities was ongoing, and the removal programs were not coming close to keeping up with reproduction. By any straightforward metric, the snake was still winning. But the picture had become more complex than the early assessments. The nest failure data was real. The native predator interactions were documented. The ecosystem was not as passive as the first decade of monitoring had suggested. What researchers working in this space were cautiously suggesting was a model that combined continued active removal of breeding females through telemetry-assisted programs, strategic Everglades restoration investment, long-term nest monitoring, and serious research into the king snake question. None of this adds up to a solution. The python is not going to be eradicated from South Florida. The scientific consensus on that point has been clear for years. What the data does suggest is that the situation is more dynamic than the worst-case models implied, that the ecosystem is not simply absorbing the invasion passively, and that management strategies aligned with what the ecosystem is already doing might achieve more than strategies that ignore it. In the early 2020s, researchers conducting mammal population surveys in certain areas of Everglades National Park began observing something they had not seen in years. Not a reversal of the declines. The 99% reduction in raccoon sightings was not becoming 50%, but in a handful of specific areas, the numbers that had flatlined at near zero began showing very small positive movement. Camera trap stations in areas with the most intensive long-term removal began recording raccoon images again. Not frequently, not at historical levels, but present, where they had been absent for years. Marsh rabbit signs appeared in areas where researchers had documented zero presence for the better part of a decade. The interpretation of this data requires care. These were small, localized signals. The overall mammal community in the Everglades remained severely depressed compared to pre-Python baselines. The recovery, if that word is even appropriate, was patchy and could not be attributed with certainty to any single cause. But researchers pointed to the areas showing the faintest signs of recovery as places where several things were happening simultaneously. Active python removal had been occurring for longer and at higher intensity. Native predator communities were more intact in these areas due to proximity to protected zones and restoration activity, and the local python density, while still high by any standard, appeared to be slightly lower than in adjacent areas. The small mammals recolonizing these patches of habitat were survivors and their offspring, moving into areas where predation pressure had dropped by some degree. It is a thin thread of evidence for cautious hope, but it is real evidence, consistent with what models of ecosystem recovery would predict if native predator pressure on the python population was having any suppressive effect. The Everglades python invasion will not be solved cheaply or quickly. The scale of the problem, the difficulty of the terrain, the size of the snake population, and the fundamental challenges of wildlife management in a system this large mean that anyone promising a rapid fix is not working from the available evidence. What the accumulating science does suggest is a direction: sustained removal of breeding females through telemetry programs, strategic expansion of Everglades restoration, systematic nest failure monitoring, and an accounting framework that recognizes the co-benefits of restoration investment rather than treating python management as a budget category entirely separate from everything else. An Everglades with more water, healthier wood stork populations, and better preserved native snake diversity is an Everglades that is doing some of its own work against the python. That work cannot be purchased directly. It can only be maintained by maintaining the ecosystem that produces it. The low-cost living lesson at the center of all of this is not a clever metaphor. It is a real finding from a decade of hard ecological research in one of the most challenging environments in North America. Intact ecosystems provide services that management programs cannot afford to replicate from scratch. Broken ecosystems require more money, more effort, and more external intervention to achieve even partial outcomes. The native predators that started raiding python nests did not save the Everglades. They did not turn the tide of the invasion. What they did was something more modest and more interesting. They demonstrated that the system was not done fighting. Even after 20 years of ecological damage at a scale few invasions anywhere have matched, the living web of the Everglades still had responses that no researcher had fully predicted, and those responses were worth paying attention to. That is not nothing. In an ecosystem context, that is quite a lot. If you made it this far, you are exactly the kind of viewer this channel exists for. The Everglades python story is going to keep developing. There are results coming from the latest Judas snake tracking programs. There is new nest monitoring data being processed by researchers at the U.S. Geological Survey. There are questions about king snake behavior in high python density zones that nobody has clean answers to yet. We are going to stay on this story, and when new data comes out, we will bring it to you the same way we brought you this. Subscribe if you have not already. Hit the bell so you do not miss the next one. And if this documentary made you think about something differently, drop a comment below and tell us what it was. We read every one of them,